Very good morning to all the participants. We had an introduction to natural language processing yesterday, and today we would do hands-on of NLP on Python. So we'll see that how we can do some of the programs, some of the things that we discussed yesterday, like tokenization and machine translation. So I would also like, as I mentioned yesterday, that I would take one of the problems, one of the research problems, and we'll see that how that it can be resolved with the help of Python also. So first of all, let me share my screen. So first of all, just write COLAB in your Google or any search engine. As soon as you write this, so probably the first result that you get, I will switch off my video just to save the bandwidth because this would require a lot of internet. The first result that comes in, you have to click on that and you would come to this screen. Welcome to Colab. I have pasted the link also on the chat box, so just you can use that. You should come to this screen. Welcome to Colab. Now, this is the last day of the workshop and almost the last session. So probably you are already aware of Colab and you are aware of Python, as what I can sense that you have already gone through a lot of hands-on on different topics. So you are the introduction to Python has already been covered. So I will not be covering Python from the very beginning. I would be straight away starting with natural language processing. I hope it has been covered. Pankaj sir, has it been covered? Python has been covered?
Yes, ma'am.
Okay, perfect. So, so I will start. I straight away start with NLP in that case. The first thing that we would be doing is I'm copy pasted the code on the chat box. Please copy it and use it. First thing that would be, I'm taking it from the very beginning. I'm not taking any research problem as of now. I'm starting from the very beginning because these are the things that you have to do in any of the problem that you're going to crack. Any problem, whether it is sentiment analysis or it is information retrieval or it is Twitter data analysis, anything, whatever you do would require these steps, which I am telling you. Tokenization of the sentences, removal of the stop words, translation of the machine language, or finding out the lemmatization of the sentence. As we discussed yesterday, that is the base form of the word. We talked about morphology, isn't it? So morphology is converting a word into its base form, which is also known as lemma. So the entire process is known as lemmatization. Stemming is also one of them. So there is a difference between stemming and lemmatization. In the sense, in the case of stem may or may not be an actual word. Like we just remove ing, ed, and so on. So the word that we get may or may not be an actual word, the base form of the word. But in the case of lemma, it has to be a word. So lemmatization is considered to be more powerful than stemming, but the implementation of stemming is very easy. So we would be seeing that, and we will also see that how we can get the unique words. So because these again are the initial steps that we do for any natural language processing process. The first and the foremost is import NLTK. NLTK is a library which is there with Python, and it stands for Natural Language Toolkit. And in that we download PUNKT. So let's execute this for once. PUNKT is another library which has the tokenized sentence tokenization and word tokenization. And we are trying to tokenize the sentence, and then inside the sentence we are trying to tokenize the word. What is a token? Token is the different the sentence is tokenized by the full stop, And the words are tokenized by spaces. Tokenize is basically the tokens which are present in the sentence, and token is nothing but the different words that we have. And it may involve duplicates also, because we have not talked about the removal of the duplicates as of now. So the first sentence is about Python, so it will have the first sentence is about Python as the 6 tokens. So if you see, let's first remove this and then see. So it will give you the different tokens which are present. So this is the first sentence, then this is the second sentence, and the third sentence. So you have three sentences, and if we print the words, so it will again find out the first sentence. These are the different words which are present. If you see, comma is also considered to be a word. Comma is also considered to be a word because that is a sentence. That is also a token. Full stop is also a token. Whatever is written in the sentence would be treated as a token. Would really appreciate, because since it is a simple hands-on, so if you are done with this, please let me know onto the chat box so that I can proceed forward. Please let me know once you are done in the chat box. In hands-on sessions have always to be interactive. If it is not interactive, then there is no point in having a hands-on session, because I do believe that you are doing it along with me. Please let me know once you are through. I am waiting for it. Open Colab and just try to import NLTK and do the word tokenization and sentence tokenization. Yeah, that is the link, Nikha ma'am, for Colab. I'm still waiting for any response from the participants that they have done with this. I'll wait for another minute, but still I am not receiving any response.
Ma'am, actually, the participants are less, and
Yeah, I also believe the same. We have 19 participants.
yes, ma'am, tell the steps in chat window what they have to do just after that link. So they
Yeah, that's what I mentioned. I have already pasted the code. I've already pasted the code. After welcome to Colab, we just have to click on file and new notebook. That's it. And in the new notebook, you paste the code that I have already entered.
Okay. Participants, reply. Please reply. Anyone have do this?
Okay. So I assume that you have done that. Then we need to install the library. The library for stop words. Pip is a command which is used to install any library which is already there with the Python and there with Colab. So we will say install stopwords. Stopwords is a library which contains the complete data set of all the stopwords present in the dictionary in English language. So you say successfully installed stopwords. Successfully installed stopwords. And now I can do import NLT and then I can download stopwords. First I have to install and then I have to download. Download stopwords. Now, once I have downloaded the stopwords library, I can remove the stopwords from the list of the words we have. What are the list of the words? W token. W token contains the list of the words. So we can simply remove the stopwords from W token. And if you see, I'm importing stopwords library and then I'm trying to print the words which were there. Then I am taking another list which will contain the stopwords which are present in English and in the list of W token, that is in the list of all the words, we will print only those words which are not stop words. I'm again repeating. I'll import the library stop words and I would print the previous words. Then for every word which is present in the list, for every word which is present, there are 24 words. Every words which are present in the list, we will print only those words which are not stop words. So let's see. This was the list of the words. And these are the words which are not stop words. See here. These are the words which are not stop words. If you see, the should be a stop word, but since it is the first letter of the sentence, it is not a stop word. If it is written in capitals, it is not considered to be a stop word. If suppose the first sentence is I write a the here and then I do this. This small the will not appear. See, small the is not here. Though it was there in the list of words, but small the is not printed because small the is a stop word. Capital the is not a stop word because it is going to change the meaning of the sentence. But this the will not change the meaning of the sentence. These are removed. See, about is also removed. About is also a stop word. I can write it like this also and get all the stop words in the sentence. So these are the stop words which were present. Is, the, about, can, and, here. These are the stop words. And if I say not in, so it will give me only those words which are not stop words. Again, I'm stopping here for a minute to see if you are able to do it till here. I'll be giving you enough time to do it at your end. There are 20 participants now. Amit, Amit sir, Anjali ma'am, Ashish sir, Mohammad Arshad, Neeraj, Richa, Sanjay. I hope you people are doing it. Okay. Now there is another way of removing the stop words by taking some words in the list and then trying to remove the stop words. That can also be done. I have taken some words in the list and I'm trying to remove the stop words. Check if this also you can do. Either I can take the words from a sentence, or I can give the words separately as a list also. So this can also be done. So these are the words which are stop words. Is the, see, is the, since there was written with capital, so it is not a stop words. Let's try using with a small. So there is also here now. If it is capital, it will not be treated as a stop word. Since it is not capital, so it will be treated as a stop word. Write it in capitals, it will not be a stop word. If you write in small, then only it would be a stop word. So if you write it as capital, again it will not be a stop word. And if I want the unique words, I'll say not in. I would really request all of you to please mute your mics. Now suppose if I want to see what are the different stop words in English, I want to check the stop words present in English. So what will I do is, I'll first import this, download the stop words which we have already done earlier as well. And we will say stop words dot words which are there in English. We can have another languages also, and we try to print those words which are from 600 to 630. Let's change it a little bit and make it 640. So it will print 40 words, 40 stop words which are present. So these are the stop words which are present in English. And if you see, these are from a different language. So probably the English is starting from somewhere around 610. So this is complete English. Let's make it French. But stop words are starting from 400 to 440 for a different language. Here it is. So if you see, these stop words are not from English. These are from a different language. Could you do it? Great, great. Less sound. Okay. Now can you hear it well? Ashish sir, now is it audible well? Am I audible? Okay. Because Ashish, okay.
Yes, ma'am, you are audible.
Okay. Thank you. Thing that we'll do is, as I mentioned you, lemmas. So lemmas are very important because that will give you the base form of the word. What is the base form? As I gave you an example yesterday also, start, starts, started, starting. So the base form for all these words is start. You can change the form as per the gender or as per the tense or as per the singular plural part, but the base form of it will always remain the same. So if you want to have the base form, then that is the lemma of the word. The lemma means the actual base form. If this base form is similar to another base form, then it forms the antonyms, synonyms. And if it is different from another base form, then it forms the antonyms. So this is the way how we get the synonyms. So what is the way? First of all, we'll download. There is another very important library of NLTK, which is WordNet. So WordNet is basically a data set which contains all the words of the dictionary, all the words. So it is very extensive and very large. It contains all the words which are there in the dictionary, and I have taken a empty list which is known as synonyms. I have taken an empty list as synonyms. Then what I'm doing is I'm finding out all the words and named it as sin and saying that what are the different words which are similar to start, and I'm comparing it with the LM in lemmas of it or lemmas of the synonyms, and we append it to this list. And then we print the list. So basically, it will print all the synonyms of the word start. Let's see. So it says start, beginning, and so on. Now let's just copy this part by to download again and again once it has already been downloaded. So there is no point in doing it again and again. And take it for another word, suppose mobile. These are the different words which are related to mobile. If you see, capital mobile is considered to be different from small mobile. This mobile is also there, but this mobile may have different meanings. So the reference to context of this mobile and this mobile is different. That is why it is appearing twice. This mobile and this mobile is also appearing twice, but the reference to context is different for both these two words. That is why it is appearing it twice. Though the meaning, though the spelling remains the same. Could you do this? You can take any word for that matter, any word for which you want to have the synonyms. You able to do it? Similarly, we can find out the antonyms also. The same process to follow. Same process to follow for antonyms as well. So I'm looking for the antonyms for the word go. Antonyms for go: malfunction, come, be born, stop, stay, no go. So the different words which can be treated as antonyms for go. Let's make it for start, finish, and stop. Because the lemma of this word is opposite to the lemma of the word finish. The lemma of start is opposite to the lemma of end. That is why we are getting these words. Okay. If you are not able to understand any of these things, any of the commands, please let me know. That is why I have started from the very beginning. That is how actually we do it. From the very beginning. Anything which is not understood, let me know. And next we come to a very interesting topic, which is translation. We can do the translation from one language to another. But as you see this error, module not found. Because in some of the versions, it is a translate, or in some of the versions, it is translate or translator. So just check which of the versions is there for you. Here you'll see that the translate is not there. So probably there is another word. I'll have to first install So now it is done. If translate is not available, please install the library. Neha ma'am, there is any problem? Neha ma'am, you want to say anything?
No, ma'am. Please continue. Yes,
Okay.
yeah.
So first you install translate, and then you write this command for translation. So from translate, we are importing the file which is known as translator, and we are to language. We are giving only the destination language. To language. What is the destination language? Hindi. And then it is asking you the input to be converted. So basically, the from language is by default English. So if that parameter is not given, then from language is English. If you want to change that, it can be done there also. And you can give one more parameter here as from underscore lang. Okay, but in this case, we are treating English to Hindi. So I'll just write, my name is Pooja. Let's see if it works. I is equal to input. It was not able to do that. Yeah. Interesting. Just 4 lines of code and you are able to convert your English to Hindi. So if any of your students say that I have made a translator, then assume that he has done only 5 lines of code. Translation is very, very easy because already there are so many libraries with NLTK, with Python, that the translation is very easy. If you also see the 5 lines of code and you are able to translate from one language to another. Here I mentioned that I'm giving 2 lang and from lang is English by default. I can give, Harman sir, you have to check whether Punjabi is available or not, or if it is available, then what is the spelling of that. Like in this case, Hindi H has to be capital, because these are the standard keywords which are present there. So you'll have to check it for Punjabi. Here if you see German and Spanish, German G needs to be small and Spanish S needs to be small. So this is a word which is in German from language to Spanish. It is converted from German to Spanish. So first of all, you should know a word in German which you would like to convert it into Spanish. Done? And Harman sir, it's a very good research field if that particular language is not present. It would really help you a lot, because in this case there are many ways of translations. If you look into the research part, there are 3 or 4 ways how to translate from one language to another. The easiest one goes with word-to-word translation. So word-to-word translation is fairly easy, and if it doesn't exist in Punjabi, then it is a very good thing, so that you have a research field on to work upon. A word-to-word translation. The only problem would be the WordNet or the data set, which will give you the dictionary basically, or it is also known as a lexicon. So the lexicon should be present. If it is present in Punjabi, then it is fairly easy to write a code for it, for word-to-word translation. And don't just go for searching of the words. You can apply indexing there. You can apply many intelligent methods of how to retrieve a word. Got it? So again, I'm stressing, whenever any of your students is doing a project on machine learning, please check it out, because probably the code is very easy, and definitely it is available on Kaggle.com. Kaggle.com is a very good site which contains, I'll just show you. Kaggle.com, it contains a lot of codes related to a lot of things, whichever you feel like. Kaggle.com, suppose if I want to go for Punjabi dataset, I'm not sure whether it is available or not. Let's see. Yeah, Punjabi news is there. Punjabi Wikipedia articles are there, and you can very well try to find out the fake news from this Wikipedia articles or old newspapers. News data set is there. Then if you see NLTK for natural languages, in the Indian languages. So INLTK is being used for Indian languages. Hindi, Bengali, Tamil, Gujarati, Malayalam, Punjabi, or are present there. Explore this. Explore this and you will get all the details. So we need to install INLTK for it. Yeah. And there is also a very important thing that we generally do is replacement of words. Again, it's fairly easy how to do it. First statement, first you give the string which you on which you want to do the experiment, and the second you replace is with was. So this is the word that needs to be replaced, and this is the word that you are replacing it with. And you can have one more parameter which will say only the first 3 occurrences of that would be replaced. The rest of the occurrences will remain the same. So if you see 1, 2, there are 2 is. Both the is would be replaced. But in this case, this also contains is. So this will also be replaced. So if you see 1, 2, 3, 4 are the occurrences of is. In the first sentence, all the 4 occurrences will be replaced. In the second one, only 3 occurrences would be replaced. If you see, the was, these 2 are replaced, and these 2 are also replaced here. But if you write 3, that means only the first 3 occurrences would be replaced. The 1, 2, and 3. This remains the same. This remains the same. And you could have done something like this also. In this case, only is would be replaced. See, is was. This will remain the same, and I can have like this. Yeah. So जो this में is था वो replace नहीं हुआ. खाली is was से replace हो गया. So there were only 2 occurrences of is, and both the occurrences of is are replaced. Got it? Good morning, Santosh sir. I hope you are doing it along with me. Now, another very important thing is replacement of the cases, because many a times it happens that I don't want to consider the case. As I mentioned in the previous one, that is, if it is written in capitals, it will not be treated as a stop word. But I don't want that. In this case, I'll have to import another library, which is RE. Then see that IT केस खाली हम इग्नोर करेंगे. रिप्लेस लाइन इज इक्वल टू सोर्स लाइन डॉट सब. ये मेरा सोर्स लाइन है. सब इज सब्स्टिट्यूशन. Triple IT is substituted with triple IT and we replace it. We are ignoring the case of triple IT. We are substituting triple IT with triple IT. By ignoring the case. The last but not the least is a spell checker. I can check the spelling of the words with this. There is an error in this. If you see, there is an error here. Indexer is not found. So I'm leaving it to you as a homework. Actually find out the solution for this error. As we did the solution to the above error, na? Translate was not available. So we said pip install translate. Remember? Similarly, I'm leaving it to you to rectify this error. What you need to install, how to do it, check it out. So we are installing the spell checker, just checking the spellings of the words. Yes, Ashish sir, I will definitely share the code with you all. Don't worry for it. So here you are getting an error. From spell checker, import spell checker. Though we have installed all the spell checkers, but still we are getting an error, and this is the homework for you to rectify. I will definitely share the files with you. So as I told you, these are the elementary methods or the processes that you have to do for any natural language processing project, for any NLP project. These are the ultimate things that you have to do: removal of the stop words, finding out the synonyms and the antonyms. Machine translation is something different, which you generally don't do, but I just wanted to cover it to tell you that it is so easy to do it. It is very, very easy to do it. So don't encourage the students writing the projects on such small things, and because these are very, very easy things to be done. And ignoring the case, you have to do it in any of your projects. So this is what I really wanted to show you. Next, I would take a project on disaster tweets. Now, this is basically, I have taken it from Kaggle itself. I took the data set from the Kaggle, and in fact, I took a lot of coding, all the libraries that I need to include. If you see this, there are 3 CSV files: train.data, test.data, and submission. Submission is basically the last file that would contain that whether the news is fake or not. So what exactly the software is all about is we have a lot of news which is available on Twitter, which there is a lot of news, and I have to check that whether this news is correct or not. And these are basically related to disaster news. If somebody says that there is a earthquake in Nagpur, so how do you check that whether this news is correct or not? So this particular project is talking about that how to check whether this news is correct or not. So first we will import all the libraries which need to be used: Seaborn, Matplotlib, TensorFlow, WordCloud. WordCloud is a very interesting library, and I would show you how to use it. And natural language toolkit is also there. We have to use all these NLTK stop words, which we did later on. Potter Stemmer is actually a stem. How to use Kaggle website? Okay, I'll tell you. Potter Stemmer is a stemming algorithm. Is a stemming algorithm, as I mentioned, stemming and lemmatization. So this is what it is: moving the stemmers, and this is a counter and cufflinks. So these are the libraries which are being used. I'll have to include these 3 files here. So I'm uploading these 3 files here. Ashish sir asked how to use Kaggle. Suppose you are looking for natural language processing projects. This is the one which I was talking about: natural language processing with disaster tweets. Since I did it some days back only, so it is showing me as the first result. Okay, let me check for it. Suppose I'm going for glaucoma detection. This is another search field, and we want to have the data set for it. So you see glaucoma. Complete code is available, which you can actually use it, put it onto your notebook and use it. The complete code is given, and you can download this 4.6 GB of data set. This is the data set of 4.6 GB. You can actually download this. If you click on this, it will download this complete data set. You give the details of this data set, or you store it into a Google Drive and give the link of that Google Drive in your program. Okay, and use this code into your own code. You copy paste this code into your notebook and it could be used. Right? So copy paste the entire code, and you can use it into your own Colab. But first you will have to take care of the data set. So as I mentioned, you download this entire data set, store it into your own computer, and then give the link of that, as I gave it here. These were CSV files which were very small. So it's maximum 1 GB of data which is there, and it was easy for me to do it. But since it is 4 GB of data, you can store it into your Google Drive and give the link of the Google Drive. Right? So I have used, first of all, you read the CSV files. You read the CSV files, which is very much required, and store it in 3 variables: train, test, and submission. I can find out how the this looks like in. So I'll check in.head, which gives you the first 5 rows of the data set. This is how it looks. It has the ID number, the keyword, which is not available as of now, and the location. This is the first tweet. Our deeds are the reason of this earthquake. Is it a disaster? Forest fire near La Ronge, Canada. Is it correct? I have to check whether it is fake or not. All residents asked to shelter in place. 13,000 people received this. Just got sent this photo from this. So I have to check that which of these news is fake. These are disaster news. If you see, these are disaster news. This data set contained only the disaster tweets, not the normal tweets. It didn't contain the normal tweets. It only contained the disaster tweets. And in that disaster tweets, I'm trying to find out whether it is fake or not. So basically, what is the process that I'm going to follow? I'm going to actually find out the unique words in this and what is the occurrence of these words with the rest of the words. If 4 or 5 people are saying the same thing, then probably I feel that it is not a fake news. One thing. And the second thing is I will check it with the news. This is Twitter. Okay, so I will check it with some Times of India news or some other news. If that particular news is available there also, then probably it is not a fake news. I'm repeating it again. See, I first of all imported all the libraries: NumPy, Pandas, Seaborn, Matplotlib, TensorFlow, BirdCloud, Matplotlib. Then T is the one which we talked about, ignoring the cases. LTK, Stopwords, stemmer is used for stemming algorithms. Counter, it is used for counting and collections, and cufflinks. And particularly here, I have made it offline. So these are the libraries which are included. There are 3 data sets: train, test, and submission. Since this is the last day of your workshop, so you must have already gone through the training set and the testing set and the validation set. So we do the training and validation from this particular data set, and we'll test it on this. This is basically the evaluation part. We'll test our model on this and evaluate our model. And then we would apply it onto the actual data set and put it onto the submission.csv, saying that, okay, this is correct, this is wrong, this is correct, this is wrong. So it would be a binary classifier in which it will give only 0 and 1. If the tweet is correct, it will give 1. If the tweet is wrong, it will give you 0. So that means if there is a disaster, it will give you 1. If there is no disaster, it will give you a 0. Understood? Train.head gives me the first 5 rows, and this is how it looks. So at present, the target is all ones. All ones means I assume that all of them are correct. And after the execution of the complete program, this would be 0, 1, 0, 1, 1, 0, and so on, saying that which of the tweets are correct and which of the tweets are not correct. Fake news. What is the shape of the training data set? It has 7613 rows with 5 columns. And test has this many rows with only 4 columns. Why? Because the target data set needs to be added to it. That is why it contains only 4. The testing data set will not contain the predictions. I have to do the predictions. Correct? So it contains only 4. This ID, keyword, location, and the tweet. Got it? You are able to do train.shape and test.shape. Then we are trying to arrange the files and find out the missing values. We are just taking care of the missing values. I'm skipping this part because it is just taking care of the missing values. And here we'll find out what are the unique keywords. There were 221 unique keywords in that. And then again, I do the missing values part. And this is the way how we are removing the stop words. And we are finding the word cloud. Word cloud is nothing if you have seen like this. So you must have seen that there are 6 phases of machine learning. The first is the preparation of the data set. Then it is the visualization of the exploration of the data set. Now this is the exploration of the data set, in which you are trying to visualize what are the different unique words present. And for these unique words, it is making a cloud-like of a structure. So it's defining a function as plot_world and contains the entire text, which only contains the unique words. And we are removing these stop words and splitting the entire and taking only the lower cases and etc. etc. And we are making it like this. So it is only the lower words, lower case words, because the case matters a lot. If it is a capital, it will not be considered as the stop word. This is basically the visualization part, where how the figure would be there, what would be the color of the figure, and so on. And this I am not executing it at this point of time because it takes a lot of time. It takes somewhere around 2 minutes to actually build this. It is more concerned towards the visualization part. It's not the machine learning model as of now. Okay. And then we are trying to find out how many HTTP sites are mentioned. So these are the HTTP sites which are mentioned here. Then we remove such types of HTTPS and we remove all the text that start with HTML. So we are removing all the websites from here. And then I'm trying to clean the text. Convert it into lower and remove the delimiter is spaces and remove all the stop words. These are some of the text that we are getting. 13,000 people receive wildfires evacuation orders in California. People receive wildfires evacuation orders, California. These are the 2 sentences which believed to be almost the same. So we say this is not a fake news. And this all is preparation of the data. Preparation of the data, that means I'm trying to remove clean text, whatever the null values are there, what are the missing values are there, and there are spaces in between. So we are removing all that part in the trained data and the test data both. Earlier also you could see that it is a replication because we are doing the same thing in the test data also and trained data also. This is for the test data. So we did everything for the trained data and the test data. And now we are trying to find out the unique words which are present here. And it counts the values. It prints the length of the unique words. So these are the unique words which are present. Fire has been is there 264 times. Forest is there 66 times. Reason is there 20 times, and so on. And it is printing only 10 words, starting from 0 to 10, although there are so many unique words. 10th of the unique words is this, and I'm printing the first 10. At any point of time, if you feel there is a problem, please put it onto the chat box. Okay. And here we are trying to find out the words which are most frequent, because then that will make the news to understand that whether the news is correct or not. And here we are splitting the sentences. Training data set and testing. And now the shape of the training and testing has changed. It is like this. 80% of the data will go for training and 20% will go for testing. That is what we are actually doing. And tokenizing the sentences, the same as we did it earlier. And then we find out the word indexes. We are taking the values of the first 15 indexes. So like, fire, news, and these are unique words, mind you, because we have already removed the stop words. And after removal of the stop words, we are trying to print the 15 unique words, first 15 unique words. So one has occurred 11 times, would has occurred 10 times, and so on. The same thing we'll do it for training set and testing set both. And now I'm trying to train the sequence and find out, now this is another word, which is in different language. Forest fire near La Ronge, Sask, Canada. So, sorry, not different language, but this is the name of the place. This is the name of the place, and we are trying to find out whether this is there in any other ways or not. We are decoding the training sequence. We're doing the padding. Padding is done to eliminate the values which are there. So we pad it with zeros and ones. That is what we have done. And at the last, we are actually building the model, the Keras model. And this is a binary classification. As I mentioned, it would be classified as 0 or 1. If it is a fake news, it will be 0. If it is a correct news, it will be 1. So here we are putting a Keras model and doing the binary classification. So the model simply says, so there are embeddings, output is of 20 and 32, and there are so many parameters. Total parameters, trainable parameters, and non-trainable parameters. So all the parameters were trained properly. There were so many parameters and all the parameters were trained. And it can be represented in the form of a graph as well, like this. With the help of LSTM, dense data, and so on. And here is actually the training time will start. So the first epoch, second epoch, the third epoch, and so on. This is already done in your previous machine learning sessions. So these are the different epochs, and we'll do it until and unless the accuracy is per the threshold. I'll be sharing this file also with you. It is being used in many researches, and you can use it for your own research as well if you want to really go for the fake news detection in any of the data set. This I have taken the Twitter data set. You can go ahead and do the Facebook data set also. So if this is the time in minutes which was taken, and here I can find out the loss. What was the loss? So this is the accuracy, 71% accuracy in the first epoch and so on. In the last epoch, I was able to get a very good accuracy of 97%. And I can plot a graph also for it. Here is the predictions. And if you see, now these are the predictions. The first news was fake. The second news was fake. The third news was correct. Like this. And I can build a confusion matrix also for it. You must have already talked about the confusion matrix. Remember, the confusion matrix is given like this. What is the actual and what is predicted? So here basically I am doing the evaluation of my model. What would be the confusion matrix? What is the accuracy? Was I able to determine that the tweets are fake or not? So this is my actual and predicted. So 74.8 is actually my true positives, and this is my true negatives, 70.8. 74.8 is true positives and 70.8 is my true negatives. And these are my false positives and false negatives, 25.2 and 29.2. So we are getting the good amount of accuracy of true positives and true negatives, but still we can improve a lot onto this. By changing the model or by doing the cleaning of the data set in a better way, we can improve on this. And similarly, we can print the submission file like this. Predictions. And this is the way, as I mentioned, this is the submission. So now the target values have changed. The first news was, this was on the training data set and this is on the testing data set. So on the testing data set, the first news was true, the second news was fake, and the third 2, 3, 4 news was true. This was on the training data set. This was on the training data set and we evaluated it and we built the confusion matrix and we tried to improve the parameters. This is all improvement of the parameters. Change the parameters and then finally we are able to get this data. This data. And these are the news which are wrong and these are the news which are. So I would be sharing this file as well as the previous file with you all. You just go through this. And if you have any doubts or questions, you can write a mail also to me at this email ID. I would love to assist you all with any machine learning problem or natural language processing problem and so on. Any doubts or questions throughout the session? So we first talked about the initial elementary things that we do with any natural language processing project. We do the tokenization, we do the removal of the stop words, we do find out the lemmas, the lemmatization and stemming, and we also remove the cases. We ignored the cases. We did that all in detail earlier. And next, I took you through an example of a project in which we are taking a data set of tweets and finding out those tweets are fake or not, depending upon various parameters. And we did a Keras deep learning model onto this. We developed a CNN model, deep learning model on this using Keras, and tried to find out the errors, tried to find out the fake news like this. We did the word embeddings also. Bidirectional STM. We use the bidirectional STM to remove to further word embeddings. Now this is more towards the NLP part, that what is a word embedding and how there is a GLOVE model is also used. BERT model is used. I just write it down there. As these can be used. BERT, GLOVE. These are word embeddings model, and BERT is a transformational model. So as in this case, it was giving you error accuracy of 77%, 74%. We can improve that if we use a BERT model, which is a transformation model. This is using a bidirectional STM. We can use some other bidirectional STM is a long short-term memory, as I mentioned yesterday. That LSTM is generally used in the case of NLP, and this is bidirectional, that it takes the words on both the sides. It will take 3 or 4 words previous and 3 to 4 words later on. This is taking a huge 32 words. It is taking previous 32 words and after 32 words. So this is a bidirectional STM. You can use it and you can also use GRU instead of bidirectional STM and try to find out the result. And then you can compare the results and form a chart. Okay. Any doubts, any questions? You can form a comparison chart by comparing the results from different algorithms. Questions?